Hi everyone, in today's challenge we are going to solve this problem. The problem name is sliding window maximum and the problem number is 239. Alright guys, so first of all what we are going to do? First of all we are going to clearly understand the problem statement. After understanding the problem statement then only we will move to the logic part. And in the logic part we are going to see how we can solve this problem. What are the algorithms, logic, data structure we are going to use to solve this problem. So everything we will discuss in the logic part. And after understanding this logic part then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript programming language, I will share one link in the description. You can go through that particular link. You can find all the solution over there, right? Fine. Now let's see what this problem says. So let's understand the problem statement. Fine. So problem says you're given an array of integer num. Alright. So one input is clear, right? Array of integer. This is the input one, right? Input one. Fine. And there is a sliding window of size scale. Second thing in nothing but they already mentioned that second input is going to be only integer. That is nothing but input 2. So two thing is clear, guys. We are given two input. First is nums array of integer. Second is an integer k, right? Fine. Now there is a sliding window of size k which is moving from the very left of the array to the very right. So let's take an array. Let's take example one only, right? So I'm going to say 1, 3, minus 1, minus 3, 5, 3, 6, and 7. So let's say this is our nums array, right? So this is nums array, and k is nothing but let's say 3. They have already mentioned k is 3, right? Fine. Now our sliding window of size, right? Sliding window of size k is going to move from the very left to the very right. You can only see the key number in the window. So let me take a different color. So at the starting, when our window was starting from very left, right? So this is the very left, right? So k size is going to be this 3 size. So I can see only this window. I can see only these three number 1, 3, and minus 1. Not any other number. This minus 3, 5, 3, 6, 7. I can't see these number, right? I can only see these number which are coming in my window of size 3, right? And it will move right each time the sliding window moves right by one position. So once I have seen this number, now my window will move right by one position. So starting from here, now my window will be from this through this 3 minus 1. Earlier I was able to see 1 comma 3 comma minus 1, right? Now I will able to see 3 comma minus 1 comma minus 3, right? My window has been moved by one position. I hope it makes sense. So earlier it was this one, but now it is this one, right? Fine. So this is the simple problem statement. Now what we need to do, return the max sliding window. Now each window we have to find the maximum and we have to return that particular element. So you can see in the first window where 1 3 minus 1 was visible. So what is the maximum number? 3 is the maximum number, right? So you can see in the output as well, the first number is 3 only, right? In the second window where 3 minus 1 3 is visible. So which is the maximum number? 3 is the maximum number, right? So second also you can see output is 3. In the third sliding window, third window, so which is going to start by from this minus 1 to 5, which is the maximum number? Minus 135. Out of this, which is the maximum number? 5 is the maximum number, right? And you can see 5 is the third number. You can see the compare with the output, right? So let me write here as well. So here in this window 3 was maximum, in this window also 3 was maximum, in this window 5 is maximum, right? Fine. And after that it's going to start from this to this, again 5 is maximum, right? And then this is going to start from which one? So I can say this is going to start from this only, right? Then this is going to start from this one. So you can see here again 5 is maximum. Here you can see 5, 3, and 6. Which one is maximum? 6 is maximum, right? So I'm going to say 6. Then 3, 6, 7. Which one is maximum? 7 is maximum. 7. And you can see output as well. 3, 3. You can let me write here. 3, 3, 5, 6, 5, 6, 7. Here also 3, 3, 5, 5, 6, 7. So I hope you are getting this one, right? So we have just divided our nums array into some windows, right? So first of all, our window was starting from very left to the very right. It's going to move from very left to the very right, right? I hope it makes sense. So this is the simple problem statement. We are given one nums array. Let me summarize this one. So we are given one nums array, right? And second thing, we are given one integer k. Now we need to take a window of size k, right? Which we are given, right? We need to take of a window. We need to take a window of size k, starting from the very left to the very right, right? We have to shift by one position, and we have to keep till we reach to the last window, right? So initially our window was this one, then we shifted one, so window become this one, then we shifted one, window become this one, then we shifted one, then window become this one, then we shifted one, become this one, then this one. Now you can see if we shift one, then we will not get a window of size scale. So we are not going to do this, we are going to stop over here. I hope it making a sense, right? So that's all, guys. This is the simple problem statement. And let's see the second example as well if you get confused here. So there's only one element, right? And the window size is also one. And it is guaranteed that, guys, you can see window size will always be less than or equal to num's length, right? It's not like you have an array of two size and your window size is less than, let's say, 5 or 10, like it will not be, right? So in the second example we have one, this length, this array, and window size is also one, so that means nothing but this is the only window which we are going to get. And what is the maximum in this window? One is the only maximum, right? So we are going to say one, right? I hope it makes sense. So there is no more window. Fine. So now, guys, let's see the logic part, how we can solve this one. We have seen the manually, right? We are going to take each particular window size and then we are going to find the maximum, then we are going to put in our result, but it's not the right way, right? Let's see the logic part, see how we can implement this. Let me write here logic, right? Fine. So guys, first of all, let's see if we do this one this way, then what is the time complexity, right? If we're going to do this way, so this is also going to give an answer, right? It's not a wrong one, right? It's also good logic, but the time complexity is going to be what we are taking every time k, right? So let me just mention here. So let's say we have nums of size, nums length, array length is n. Let's assume array length is n, right? And every time we are just going to take this k size, right? K size of window. So we are going to say n into big of we can say simple n into k, right? This is going to be the time complexity because on each iteration we are going to take k size of window, right? And we are going to find a maximum, so we are going to traverse over this k size. So we can say for each particular thing, for each element we are going to take k's time complexity, we are traversing k time for each index, and we are going to do this for n, right? So time complexity is going to be big of log of n into k. So this is going to be our time complexity. I hope it making a sense, right? But we don't want this particular time complexity. We are going to do this. So you can see k is also going to be approximately equal to nums, right? N. So we can say 10 is to 10 is going to be the time complexity in the worst case scenario, which is not a good way, right? So let's see how we can solve this, how we can optimize this. But I believe, guys, you can implement this logic. If we are want to implement, you can implement this logic. It will going to give a correct answer, but maybe it will give you a tally, right? Clearly. Now let's see how we can solve this with the optimized banner. So I'm going to take a simple first array only. So what is that? 1 3 minus 1. Let me write a 1 3 minus 1. After that we have 5 minus 3 5 3 minus 3 5 3 and 6 and 7. I hope it is right. Fine. Now, guys, what we are going to do, we are going to say we have this array, right? So we don't want to take every time this window, then this window, then this window, then this window, right? We don't want to do this, right? Why? Let me show you one. So here I'm going to say, can we take a single data structure we are going, which is going to maintain the maximum number every time. So we are going to use a data structure called well, let's say not q, let's say deque, right? Why deque? I'll tell you. We can do with q as well, but it will give us some case it will give a TL, not TL. It we have to do a complete search on it, right? So deques will be better here. So what we are going to do here, so let's say I have a deque, and let me write here deque, right? So I have this deque, right? It is empty right now. So what I'm going to say, this deque will only contain at max k size number, right? At max k size element, and all the elements will always going to be in decreasing order. I hope it makes sense. Decreasing order means non-increasing order, right? Fine. So let's start from the beginning, right? This is 0 indexes, 1 indexes, second indexes, third indexes, fourth indexes, fifth index, sixth index, seventh index. I have written all the indexes over here, and you can see all the things is going to play a very important role here. Keep in mind, guys, deque, indexing, numbers, non-decreasing order, everything, non-increasing order, everything is going to play important role here. So what I'm going to do, I'm going to say, fine. So I'm going to say the key is 3, right? At max, this deque will going to hold at 3 size, right? Fine, it makes sense. So I'm going to insert 0 element in my deque. So now removing from here, I'm going to insert here. I have inserted this in my deque, right? It's going to hold at max 3 element, right? So I've inserted 0. I've inserted an index, not element, remember. Fine. Then I'm going to insert 1. So if I'm inserting a 1, think, see guys, 1 is 3 and this is 1. Not here, you can focus over here. So 0 indexes we have value 1, right? And 1 index we have value 3. If I insert 1 here, 1 index, so is it even gonna be in an increase, non-increasing order? No, it will be in an increasing order, right? It will be gonna in increasing order, 1, 3. But we don't want it. We want our deque should be in decreasing order, means non-increasing order. So I can't insert 1 here. If I have to insert 1, I have to remove 0. And that's what we are gonna do. We are gonna remove 0. Why? Because 3 is greater than 1. 3 at 1 index, we have element 3 which is greater than 1, right? So we have inserted 1 index, we have removed the 0 index, right? and then this makes sense, right? I hope it making a sense, right? Fine. So what we are going to do now, guys, we are going to say, okay, now we are going to take second index, right? So second index, now starting from here, see, starting from here, we are going to take our result array. Why? Because these two element will not going to play any role, because as we know our k is 3, means window is going to be 3 side. So this 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 if you focus here, so every element is going to come, but this first two element is not going to play an important role here, right? Why I mean here is, guys, if you, I have inserted first two element over here in this material, right? I have inserted first two element, but I need to take a element, maximum element, from this particular window, right? From this window, I have it making a sense, right? From this window I have to take my maximum element from second index, right? So now I'm going to take a second index and I'm going to say this is minus 1, right? This is minus 1, so I'm going to insert minus 1 over here. Not minus 1, I'm going to insert 2. Why? Because if I insert 2 index here, so I know first index was 3 and this is minus 1, so it is decreasing order, right? I've indexes 2. Now I'm going to say fine, whatever the element at first, which is at index 1, so whatever the element here, let it store in my result. So first, that is my one index. So one index has a 3 value, so we are going to store 3 in my result. I hope it making sense. No, don't worry about this, just give me a little minute, right? Give me a 2 minute, then you will have better understanding. I know it's getting quite confused, but give me just only 2 minutes, right? So 3 I'm going to insert over here. Let me take a different color. So this is going to be my final result, right? So 3 I'm written here. Now as you know, guys, from first two element we have inserted without taking any result value, right? I told you already that first two element, because case 3, so 3 minus 1 is 2, right? So I have to take first two element, which I have to take first two element in my deque. After that only we're going to start taking element which is going to play very important for our result, right? So forget about this now, everything, just keep please put a consideration of this particular part, that now we have taken a second index minus 1, second index we have inserted my deque. Fine. Now we have inserted it, now I have to take maximum value. The maximum value is going to be always the front value, because this is in non-decreasing order. Our deque is in non-decreasing order, so whatever the value at the max at the front is going to be always the maximum one, right? So first index, we have first index, and the first index we have 3. So 3 is going to be our result for this particular window, right? I hope are you getting this part, that why didn't we take a result on 0 and 1 indexes while we were putting in deque? Because first 0 and first 2 index we don't need to take care, because the window size is 3, right? So we have to at least make our window till this index, right? Now we are going to take a third index, and third index is having a value minus 3, right? And you can see we can put in my deque. Why we can put in deque? Because in deque this is 3, this is minus 1, and this is minus 3, and you can see this is still in non increasing order, this is still in decreasing order, so we can put third index here. I have putting a third index, fine. And now I have to take again a front element, because front end element is going to be the maximum, right? So front element is 1, which in at one index we have 3, again we are going to put 3. And why I have taken a front element? Because front element will tell us that what is the maximum element, right? Fine. And now we are going to move ahead. See, we are going to move ahead, and we are going to say it is index 4, right? So 4 having a value 5. Fine. So 5, can we insert 5 here? Just let me know. Can we insert this 5 here? Means fourth index. Can we insert fourth index having a value 5? Can we insert? If we are going to insert, this is going to be non-increasing order. This is going to be increasing order, right? You can see 3 minus 1 minus 3. It is still in decreasing, but here you can see we got a value which is not less than minus 3. So this is breaking our order, breaking our decreasing order, right? So we can't insert 5 here. We can't insert fourth index. Why? Because this is not in a we can say decreasing order, right? So we have to remove minus 3, this particular 3 index, because if we do this, can we getting now decreasing order? 3 minus 1 5. No, still we are not getting. We have to remove this one. Still we are not getting. We have to remove 1 as well. Now you can see we are going to get only one element, which is 5. Right? Now it is in no decreasing order, right? So I hope it making a sense. Now we can set fourth index here. So if we are doing this, after that we have to take first element of deque. So which is nothing but fourth index. Or at fourth index we have value 5. So we are going to say 5. Now let's insert the fifth index, which is having a value 3. So if we are going to insert a fifth index, let me change the color here. So is it going to be in decreasing order? It has value 3, right? So you can see 5, 3. Yes, it is in decreasing order. So we can easily insert this and take the front element, which is nothing but fourth index. So fourth index value have 5. Again, a 5 is going to be our result. I'm going to repeat everything, guys. Just give me some time, right? Fine. Now we are going to take a sixth element. Can we take a sixth element here? If we're going to take a sixth element, so let me just, okay, let me give you undo. So what I'm going to do, I'm going to say if I'm going to take a 6 element, so this was 5, this was 3, 6 element is 6. It is going to be in decreasing order? No, right? I have to move 3. Is it still in decreasing order? No. I have to move 4 as well. Now it is a decreasing order, right? So I have to write here 6, and this has a value 6 only, right? So it is decreasing order, right? Now after doing this, we have to take a front element, which is nothing but 6, right? So 6th index we have value 6. So we are going to say 6 is my next element, which is the maximum element of this window. Right now I'm going to say take a next index 7. So can we write 7 here? If we write 7 here, which has a value 7, it is in decreasing order. You can see guys, it is not in a decreasing order, right? So 7 is not in a decreasing order, which have value 7, right? So we have to remove this 6. Now we can say 7 is in itself, it is a number which is in a decreasing order, right? So remove the first element, take the first element from deque, which is nothing but 7 index. At 7 index we have value 7, so we are going to write 7 here. I know it's quite confusing, but for now we have completed this, we can say traversal. Now let's see, let's revise this. So first of all, let's see whether this is our right answer or not. 3 3 5 5 6 7. You can say 3 3 5 5 6 7. Now how does it came? See guys, now we are going to understand again this thing. Now you will have attention. First of all, we know case 3, right? So we will never get our window of 2 sides, right? So we have to make at least 3 sides of to make a window, right? So that's why I have put first 2 element directly here, 0, 1, if they are in decreasing order. If they are not, so I have put only 1. Why? Because now 3 is in decreasing order, right? Now from this, so I have put first index here. Now I have going to take a next element here. I'm going to put it over here, and if I take this element, so you can see this is going to give us a window. So let me remove all this thing. So this is we got already. Now I am going to take, you can see I have just put first 2 element. Why? Because this is not going to make any window, right? So I put first 2 element, and I haven't put like this 0 1 because these are not in decreasing order. So I've removed 0. I've just keep it 1 only. Now this is in decreasing order. Now as soon as take this element, so if I take this element, so this is going to be a window, give me a window, right? Right, it's going to give me a window. So as soon as take 2, so this give me a window, and in this window, what is the maximum value? That maximum value is going to be always front value. Why? Because this deque front is going to tell us that what is the because this is no decreasing order, right? So this deque dot front is going to tell us that what is the maximum value of this window, right? So we are taking this particular index and we are putting in our result, which is 3. At first index we have 3 values, right? Now once we done this, now what we are going to do? We are going to take a next element, right? We have taken a second index, right? Now we are going to take a next element 3, and we are going to put it over here, right? I hope it making sense, right? So once we have taken 3, so our window should be this one, right? So if we are having a at front element, this one element, right? This 0 index, we are going to remove it. But you can see guys, there is no 0 index in this my deque, right? I hope it makes sense. If it is going to be, then it will always going to be at the front, right? If it is going to be, then it will always going to be in front. So before doing that, we are going to check just. We are going to check if 0 is in my front. If it is so, remove the deque dot front. Otherwise, don't do this, right? As you can see, deque is not in my front. So I'm going to do nothing. I'm going to insert 3 because now it is in decreasing order as well. 3 minus 1, 3 minus 3. And if you do insert 3, you can see guys, we have to take a maximum value from this window, right? We have inserted 3 index, right? So the maximum value is going to be always the front element of this deque, which is nothing but 1. The 1 index we have value 3. Now what we are going to do, we are going to again insert 4th index over here. But believe me guys, if you are inserting a 4th index, let's say the 4th index having a value minus 5. Remove all these things. Let's say 4th index having a value minus 5, right? So if 4th index have value minus 5, so I'm going to insert here 4th index, right? It makes sense, right? Because 4th index is minus 5. It's still in decreasing order. 3, minus 1, minus 3, and minus 5. It is in decreasing order. But you can see guys, after inserting a 4th index, I have checked. Is the first index, see, this is our window, right? If this last index, right, first index is equal to my deque dot front, then remove this one. I have to remove this one. I hope it makes sense, right? Because I don't want to take a window more than k side, right? I have to remove this one, and now you can see we have minus 1, minus 3, minus 5, and the front element is 2, right? And front element is 2, then what we are going to say? We are going to say at second index, whatever the value, that is the maximum value of this window, and second index will be minus 1. So minus 1 is the maximum value of this window. You can see minus 1, minus 3, minus 5 is the maximum value. Minus 1 is the maximum value, right? Fine. So I hope you are getting this point, right? So we are also not taking the value. We are maintaining this deque as a maximum, or we can say decreasing order, and we are just keeping only k element, at max k element in this our deque. I hope it makes sense. Let's move to the implementation part. There you will have better understanding what we are going to do here. So with the code part, if you're still not getting, just let me know in the comment. But I believe guys, if you're still not understanding anything over here, with the code part, each line by line, I will going to teach you that how this is logic going to work, and there you will have better understanding, right? So let's move to the implementation part. And guys, in the implementation part, what we are going to do, we are going to say first of all with Python. So I'm just simply going to say I'm going to make a deque, right? So deque is going to be collections to deque. And one thing more, that is nothing but an array, which is going to be a result, right? So let me write a result only. Fine. So what I'm going to say, insert first of all, four I in range of k minus one element. K minus one. I hope you are getting this. So k was 3. So we have inserted first two elements 0, 1, right? So I'm going to say while my deque and deque dot we can say deque of minus 1. So deque of minus 1 is going to have index. So we can say nums of deque of minus 1. This is we can say less than nums of 5. So this is the case only, right? So let me just give a case here. So let's say there was nothing but 5 only, right? So if it was 5, so what we were doing, we were having this one, right? 3. So index 1 was there, 2 was there, 3 was there. So we are going to insert a fourth index. So for inserting a fourth index, we were having 3 value, minus 1 value, minus 3 value. So for inserting a fourth index, that means we are going to insert 5 value, right? And if we insert 5, this is going to be non-decreasing. This is going to be in increasing order, right? And we don't want increasing order. We want decreasing order, right? So we have to keep popping until we get the next value. Last value is greater than this 5, right? So we are saying same thing. Nums of deque minus 1 is less than nums of 5. If it is less than this, you can say this is minus 3. If it is less than 5, right? If it is less than 5, keep popping, right? So deque dot pop, right? Fine. And here we are going to say after doing all this thing, deque dot append this nums of 5, right? And you can see this is the best example which I am going to give here. So see, we are going to pop minus 3 because it is less than 5. Minus 1 is also less than 5. Minus 3 is also less than 5. We are going to pop all these things. After doing all these things, we are going to insert 5, right? So we are going to insert 5. We are going to insert deque dot append nums of 5. Fine. After doing all these things, then what we are going to do? We are going to say fine if. So here guys, we are going to say not if. We are going to say now let's move to the rest of the element for I in range of from k minus 1 to length of nums, right? Now rest of the elements. Here what we are going to do? We are going to say same thing, right? But here one thing is going to change. What is that? Let me show you. So first of all, I'm going to copy same thing. The one thing which is going to change is that we're going to put also in our result as well, right? We can say put in my result, but before that, check if k minus I minus k is equal to deque of 0. So this is the same condition, guys. If we get our element which is the out of window, right? So we have to remove from deque, right? So let's remove from deque dot. We can say pop left. I will make sense. So deque dot pop left. After that, we have to put this element, whatever the element at the max at the front of deque, put in our result. So in result dot append, what we are going to append? What are the element at the deque of 0, right? So deque of 0 is going to be the maximum element, and we are going to say this is going to be nums, right? Because nums is an array. This is going to give us index. We are going to calculate the num element, and then we are going to append in the result, and then we are going to say return result. Let's see whether it's working fine or not, and I believe it will work, right? Let's see. And you can see we got an error. Why? Because it's saying nums deque of 0, right? So let's see whether we have done something wrong over here or not. So let's in list index out of range, right? So we are appending nums of 5. This is the wrong thing, right? We have to append only index, right? We don't want to append number. We want to append an index, right? In deque, we'll always wanna have index, right? Now let's see. And you can see, guys, both the tests passed. So let's try to submit this code, and we will definitely gonna submit as well. Simple thing, guys. If we got our deque length is gonna go out of window, or we can say if we get element in non in increasing order, or we can say if it is not following a decreasing order, then we have to keep up in the element and we have to make it in non increasing order, right? Fine. Now let's see the next programming language, which is nothing but C++. If you still have any kind of doubt, you can write in the comment section, right? But I believe first try to solve it by yourself in the copy and paper. Just we are following a deque and we are following a non-decreasing order, right? And we are always putting an index on our deque, right? Not any element, right? Fine. Now let's see in the C++. First of all, we have to make deque, and we can say this is deque, and then we are going to say vector of result. Fine. Now we are going to say for int I is equal to 0, I less than k minus 1, I plus plus. Here we don't need to insert anything in our result. So k minus 1 element is we are going to put in results. We are going to say for. We can simply while, like while our deque is not empty. Deque is not empty, and nums of deque front, right? Deque front is less than nums of 5. That means this is not following a decreasing order, right? So we have to pop deque dot pop back, right? And we don't need to use front, we need to use back, right? Fine. Once this is done, then what we are going to do? We are going to say simply deque dot push back. And what we are going to push? We are going to push only an index, right? Fine. After doing all these things, we are going to move to the now for int is equal to k minus 1, from k minus 1 to the rest of the numbers. So nums dot size, right? And a plus plus. And here we are going to say, just copy this two line. This is going to be remain same. But the thing is only which we are going to change is nothing but we are going to say copy this. We are going to change only one thing, that is nothing but now we have to insert in our result as well, right? Whatever the element at the front. So after that, we are going to say if our first of all check if I minus k is equal to deque dot front. That means we don't want to take this one, deque dot o front. Right, this is not in our window. After doing this, what we are going to do, we are going to say simply result dot, not result, yeah, result only, result dot push back. And what you are going to push, you are going to push your nums of deque dot front, because deque dot front is going to give you only index, right, not element. So you have to calculate from the nums array. After that, you can return your result. Let's see whether it's working fine or not. And I believe, guys, it should work, right? Let's see. And we got an error. What is deque dot front, right? Its spelling is mistake. Let's see now. And I believe, right, it should work. Let's see. It's taking a time. Do we have done something wrong here? So you can see, guys, both the test case passed. So let's try to submit this code. And I believe, guys, it should submit, right? So you can see, guys, it successfully got submitted. Now let's move to the next programming language, which is nothing but you can see Java. And in the Java, first of all, we are going to maintain a deque. So deque integer deque is going to be nothing but new array deque. Fine. And we are going to make one array because we have to return array, right? So we can say array, and let's say result is going to be new int how much element is going to be there. So we can say nums dot then minus k, and one we have to add. This is going to be the size of an array, right? You can check it also, guys. Every time you will get this particular size of your result. If nums length minus k plus 1 is going to be always the size of your result, right? Now we're going to use our same logic for int I is equal to 0. First of all, let's take all the k minus 1 element and insert them over deque following the decreasing order. But if it is not following, if deque dot is empty and deque dot, what we can say, deque dot is empty and deque dot front. So we can simply say deque dot peak front, not front, peak last, right? Peak last, and this we have to take in nums, right? So nums of deque dot peak last is less than what, it's less than nums of I. Then what we have to do, we can say deque dot poll last, right? So we have to poll from the last. Fine. So now we are maintaining a decreasing order. Once this is done, we are going to insert our deque dot of for last. Which element? Our I index, right? Once this is done, then what we are going to do, we are going to say fine. Now we have inserted all k minus 1 element. Now we are going to insert it all the elements which is left after k minus 1 index, right? So we are going to say I is equal to k minus 1, I less than nums dot length, and I plus plus, right? And here we are going to say after doing all these things, then you have to insert your result as well. But which element you have to insert? The first element of the deque, right? And before that, check if deque dot, if I minus k is equal to deque dot front peak front. I haven't used a bracket, guys. This is a method, not a variable. Fine. So if deque if I minus k is equal to deque dot front, I minus k will tell us that what is the index of what is the last index of your window, right? And last index means, guys, if you have this window, right? If you have this window 1 minus 1 3 5, so I minus k is tell us this particular index. If this is coming at the front of your deque, then what you are going to do, you're going to say remove this one, right? So how you can remove this one? You have to remove the first index, so deque dot or front, and after that you can say result dot pushback, not pushback, this is a integer, so result of index plus plus is going to be what we have, it's going to be nums of I, no, not nums of I, nums of deque dot peak front, right? Fine. Now you will, guys, be telling what is index, right? Let's see here everything. So guys, we have created an array, right? So array is static, right? So we can say int index is always going to be starting from 0, and every time we are going to insert in our result this index, this array index should be incremented by 1, right? After that we can say simply return result, and let's see whether it's working fine or not. So let's see. And it's taking a time. I think something is in here. Let's see. All right, so it's taking a lot of time, right? So let's see. Just give me a second and let me change the internet as well if something is issue from my internet. So let's see whether internet is working or not. So internet is working fine, but it's taking a time. Why, I don't know. Deque.peak front cannot find a simple peak front, right? Alright, so not front peak. So what could be here, right? So let's see. So I minus k peak last. Alright, so let's see peak first. I don't know, guys, what's happening over here. Let's see. Yeah, it's gonna be peak first one, right? Peak first, hold first. Now let's see whether that's working fine or not. So you can see, guys, both the test case passed. So let's try to submit this code. So the only mistake was there is no method peak first, peak front, pole front. There is a method peak first, first, right? Pole first. Now, guys, what we are going to do, we are going to see the next programming language, which is nothing but JavaScript. And the JavaScript, same thing we are going to do. First of all, we are going to define a queue. We can say simply const deque is nothing but simple array. Const result is going to be nothing but simple array. We are making a simple array, right? Now, what we are going to do, we are going to say while. So for let I is equal to 0, I less than k minus 1, I plus plus. For k minus 1 index, we don't need to put in result something, right? So we can say while our deque.length is greater than 0, and so this will tell us that deque has at least one element, and deque of right nums of deque.length deque.length minus 1. This will tell us the last index, and what is the element at the last that index is if that element is less than nums of 5. That means it is not following a decreasing order. So we have to remove deque dot what we can say deque dot pop, right? Fine. And after the deque dot we can say push. What we are going to push? We are going to push I, right? Fine. So once this is done, then what we are going to do? We are going to say fine. Now let's move to the rest of the index. Then we have to put in result as well. Let I is equal to k minus 1, starting from k minus 1, I less than nums dot length, and I plus plus. And here we're going to say same thing, right? So why don't we copy this one? So let's say just simple thing. We are copy this part, right? And we're going to put here. Fine. And here after doing all these things, what we are going to say? We are going to say first of all check if I minus k is equal to deque dot what? So deque of 0. If it is so, then you have to remove deque dot shift, right? You have to remove the first element of deque. After doing all these things, then we are going to say put in my result dot push. What you are going to put? You are going to push deque of nums of deque of 0. Fine. Now at then you have to return simply return result, right? Let's see whether it's working fine or not. I know this problem is quite complex, but believe me, guys, if you do one by yourself on copy paper, you will I will say easily solve it, right? So we got an empty array. Why it is empty array? It didn't push anything over here, right? So length. So this is going to be an undefined, right? So let's see now. And here also, guys, length. Yes, I don't know why I have done this. length. Let's see now. Do we have any mistake or? So you can see, guys, both the test case passed. So let's try to submit this code, and I believe, guys, it will gonna submit. So let's see. You can see, guys, it successfully got updated, right? So we have done the implementation in Python, in C++, Java, and JavaScript programming language. If you have any kind of doubt in the implementation part, logic part, problem understanding part, you can write in the comment section. I'm always there to help you. I know this problem is quite complex, but believe me, guys, once you try to write the code by yourself, once you will solve by yourself on copy paper this any particular example, you will easily able to understand it, right? So if you learn something new in this video, at least one thing new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video, right?